Hello again, everyone. So let's go ahead and talk about trigonometric equations that have no solutions, because you can come across those type of trig equations. So I just gave you a couple of examples. Let's look at the first one. We want to solve this equation for x, the angle x. So let's go ahead and do that. So that would be 3 sine x equals to 4. We are isolating sine x, divide both sides by 3, and we get sine of x equal to 4/3. Okay, and the very first thing that you notice is that sine of x cannot be, it has to be between -1 and +1. Okay, the original sine function can't be greater than 1 or less than -1. And if you remember the sine function graph, those are the minimum and maximum values. So there are no values of sine of x that are greater than 1, and that means that there is, or there are, no solutions. No solutions to this equation. Okay, no solutions, and simple as that. You just stop. There are no values of theta or x in terms of angle that gives you 4/3 for the value of the function. Let's look at the next one, the cosine one. Same idea. Let's isolate cos x. Here we go. Divide both sides by 2, and you get cos x equals to 5/2. Well, same idea applies here. Cos x, the original parent function, cannot go less than -1 or greater than 1. So because of that, and since 5/2 is greater than 1, we say again that there are no solutions. Okay, simple as that. So you may come across questions like this, and just pay attention to the maximum and minimum value of the original parent function of the sine, tangent, and cosine, and then just make a note that there are no solutions. All right, very good. So the next part I'd like to talk about is the reciprocal of the trigonometric functions and equations. Now, you may have seen this in grade 11, but I'd like to review that again in case. So the reciprocal of a sine x is 1/sine x. So that's called the reciprocal. Remember, for the reciprocal functions, if you have 1 the original function, that becomes a reciprocal. Now, 1/sine x in trigonometry, we call that a cosecant of x. So cosecant is 1/sine x. And cosine, 1 the reciprocal of a cosine function is a secant function, and the reciprocal of a tangent function is cotangent function. Okay, now a couple of things you need to pay attention to. Now, because these are reciprocal functions, that means if you remember, most of the reciprocal functions, they have non-permissible values, or NPVs, or asymptotes. Okay, so asymptotes or non-permissible values that you must know are the values in which makes the denominator equal to 0. So in this case, sine of x, what are the values of sine of x that makes sine of x equal to 0? And if you remember, as the very parent function, x is 0, and let's deal with the radians measure, pi and 2 pi. These are the values that make that reciprocal function undefined. So cosecant of x will have asymptotes at x equal to 0, x equal to pi, and x equals to 2 pi. And we're going to graph that shortly. Let's look at the cosine of x, and then the reciprocal of that will be the secant of x. So the asymptotes or non-permissible values again, let's look at cos of x equal to 0, and that means, by the way, these are not, it cannot be equal to, right? That's what we are trying to find out, the NPVs. In this case, x cannot be equal to pi/2 and 3 pi/2. Okay, and that means the equation of the asymptotes are x equals to pi over 2 and x equals to 3 pi over 2. These are the equation of the asymptotes right there. Okay, so that's it. With tangent, same idea. Now tangent already is a reciprocal function because it's actually a rational function, because you have sine over cosine. So another way of writing that is 1 over tangent of x, which is cotangent of x. So in this case, the asymptotes are where tan of x equals to 0. And if you remember, that would be x equals to 0. And the next one will be x equals to pi. All right. And in this case will be, you cannot have those, right? So therefore, the equation of asymptotes equals to 0, x equals to pi. All right, now let's look at the graph of each of these. This is the graph of y equal to sine x. That's the original parent function. And look what happens when we do 1 over sine x. And remember, at 0 and at pi and at 2 pi and any of the other x-intercepts of the sine function, we're going to create what is called as asymptotes. So when I engage the cosecant, and notice what is happening. You have one part will go up, one part go down. It almost looks like a parabola. Now, 2 of these, so this one and this one, they represent 1 full cycle for a cosecant. That's the period of the cosecant of x. Okay, but notice that the asymptotes have changed. So 0, the vertical line, x equal to 0, and x equals to pi. And as well as x equals to 2 pi, those are your vertical asymptotes. And of course, if you continuously going through the general solutions, you can go ahead and write up many asymptotes. Every time that you come across the x-intercepts, that becomes an asymptote, and then so forth and so on. All right, let's look at now cosine and secant. So this is the cosine function. Very good. And then same idea that gives you a typical graph. Sine and cosine, they're very related to each other, and same thing happens again. In this case now, your asymptote is pi over 2, negative pi over 2, as well as 3 pi over 2, and continuously goes. And notice that there is no minimum and maximum value, but there is an area in between the two curves. So this top one and the bottom one, that represents 1 full cycle. There's nothing in between. Okay, and that's basically it. So let's look at tangent and cotangent. So tangent, we already know it has asymptotes for every pi interval starting at negative pi over 2, or we can say every pi interval going from pi over 2 on and backwards. And now when we engage the reciprocal of that, notice that you have 0, which was the original x-intercept of the tangent function. That is now created. The asymptote has been created at x equal to 0, x equal to pi, and then every other interval of pi, the asymptote is created. And notice that the graph of the cotangent is actually pretty much a symmetric graph that goes flips over in halfway, pi over 4 in between. Okay, if x equal to pi over 4, if that's a reflective axis, the graph has been flipped over there, and that's what you will get. Simple as that. Okay, so these are all representing the reciprocal of the original primary functions. So to put it all together, for the first graph, we have the reciprocal of the sine function. That's the cosecant of x right there. And these are your vertical asymptotes. One is in here, one is in there, one is in there. I just chose the 0 to 2 pi interval for the sine function. And here it is. That's what that is. And these two-piece blue graph represent the cosecant of x function. We go to the next one. That's the reciprocal of the cosine function. The green graph is the graph of the cosine function, and the reciprocal of the cosine is a secant function. These vertical, again, dotted line, there are the asymptotes, and they continue, right? I stop drawing them, but sure enough, you can see that there is another one here at 5 pi over 2, and so forth and so on, every time that the graph crosses the original graph crosses the x-axis. Okay, And remember that two pieces of these represent a full function. Okay, so a full function. So this and this together that represent one function, and in this case both of them, basically the period will be 2 pi, so as the cosecant of x. The tangent, same idea. Reciprocal of a tangent is cotangent. The red graph is a cotangent of x. The black graph is the tangent of x, original function, and sure enough the new asymptotes have been shifted, and that's what you will get at 0 and at pi and at 2 pi. Okay, that's basically it for reciprocal of the trigonometric functions.